There is a really cool idea, very important idea in object-oriented programming. We are trying to capture common stuff, right? So if you write your classes, right? We talked about classes. If you write your classes so that you never show any of the fields, right? You only have um, methods, right? Um, you will find that many times you have classes that have similar methods, right? We can, in Java, express that commonality on the methods through an interface and use it to write code that is polymorphic. That's really cool. Sounds like a really cool word. It means many forms, right? So you can have different implementations of this interface. So we'll define the interface in Java, which is the method that you can call, and then you can have different implementations of that interface, and at runtime, Java will bind to the right one. And so you can write code that would work on many different classes. For example, imagine that, and I think this is the next assignment. We want to do a geometry program for little kids, where we're going to talk about area and perimeter, right? For geometric figures, right? So we could define a rectangle class, right? That would have width and height. And interfaces get area, get perimeter, and toString. Right? Methods get area, get perimeter, toString. Right? And get area is just width times height, right? Get perimeter is 2 times width plus height, and toString we just define it, right? To print something. Well, it actually returns a string, then eventually Java will print something. This idea makes sense. Yes?
Do you always have to have toString with every class?
You don't have to. If you don't, Java will define one for you that will print a horrible number. That will print, I think, the name of the class and then a horrible number. That is the address in memory that the object resides. So it's not a very useful thing. It's there. So you don't have to define it. You probably want to define it. But so let's go here. And actually, I have this now exported. If you go to this place, click on resources, and I will send an email, but I lied to you. Oh, it's right here, sorry. Sample program. No, this is not. This is the old one. Lecture examples. So this is the stuff that we have done up until today. Like this is last class. And if you guys remind me, I will push the code as we do it. I'm also uploading the videos I had skipped. Like I had been uploaded in like a week, so now I'm uploading. But so let's create one more thing. Let me create a package so we can have so inside, let me create a Java class, call it rectangle. Delete this horrible stuff, and then cut and paste this. Not this, but this. Isn't this cool? Make it prettier. Any questions on classes and the rectangle class? It's a method. It's called what? ToString, and it returns a string. So in Java, ToString, you can define your own ToString to kind of describe how it should be printed. And when you call system.out.println on that, it will print whatever that thing returned, as opposed to.
Oh, that's cool.
Sorry? Width and height are variables here. We are creating a string that says rectangle, square brackets, width, colon, and then the actual width, height, colon, and then the actual height. So it would do rectangle, width 10, height 15, right?
So out that print or out that print line will, for any class that you create, if you make a ToString method, it will print
Yes.
that. Okay.
Let me create this main, and then we can do that. So we can do rectangle. Ah!
It almost makes it seem like Java's like cool,
It is.
not the worst language.
There's only two types of languages. The ones that people complain about and the ones that nobody uses. So Java is widely used. Don't get me wrong, it's a piece of manure 4 days out of 5 when I'm fighting with it. But it's actually not a cool language anymore. But it gets the job done.
Well, when was it cool? Like 1992?
1995, when Java came out, it was amazingly cool. I mean, compared to C++ at the time, God, it was amazing. Like, it had garbage collection, which wasn't used before. It wasn't popular before, except in other, like, wasn't popular in common languages. It had garbage collection. It had a virtual machine, which was a lot cooler than hash defines and hash includes and hash if def in C and C++. It came with a library, graphics as part of the library. The graphics library sucked, but it was a GUI library that came with the language, right? Had a networking library that actually came with the language, and it's very, very nice compared to the stuff at the time. And so compared to the stuff in 95, Java was amazing, right? It's just,
Everything else caught up to it.
yeah, everything. And there were other things that caught up to it, and now Java has there is tons of stuff in Java, so I need to be backwards compatible, which means I have to be ugly and keep ugliness around. And so,
Are there some languages that are less secure than other ones? Like
secure.
so I don't like.
Secure is not a property of the language.
No, I mean like if you have like websites with like JavaScript and other stuff on there, like then there's like ways that you can.
There are a couple of things. There are several things, right? There is a security problem with C in that in Java, right? And that's cool because we just talked about arrays. In Java, you define an array and then you try to access an element outside the array, right? What Java does is it complains and doesn't let you, right? In C, if you allocate an array and then try to access an element outside the array, C will happily access that element outside the array, which is another place in RAM which may or may not have anything to do, may or may not be safe, right? May or may not contain the operating system, right? And so if you don't write your program right, people could exploit a hole in your code, right? So that they override the operating system in RAM or something like that, right? So those are buffer overflows and those kinds of things. In languages like Java, you can't have those problems, except when you call C libraries, and everybody does. So that's kind of the only thing where Java is more secure than C. You can still screw up, but it's a lot harder to make certain classes of errors. The other big thing that has nothing to do with the languages is who programs in that. So, for example, PHP is a horrible language, but it's a very insecure language, not because there's something wrong with PHP for security. It calls C libraries like everybody else, and so you may end up. But people who don't know much programming tend to program in PHP, and so there is a lot more insecure PHP code out there just because the people who wrote it are inexperienced and that kind of stuff. And it becomes part of the community. So now the examples that you see in Stack Overflow have insecure code examples, right? And so that makes it, other than that, you can write secure or insecure code in almost any language. It's also kind of the defaults that they choose. The defaults that they choose and the examples that are documented would be what people do. And so if they choose more secure defaults, that would be good. But anyway, so
I'm just curious to like you have to enable Java in order to use like applets on web pages, so it just seemed like by default people.
Java on applets, right? Java was relatively secure compared to other things, but Java now is not used for applets anymore. Java is used on the server side mostly, and also on Android. Your phone runs Java. Well, my phone runs Java. Half of you have iPhones. The other half have Android. If you have an Android, your phone runs Java. But a lot like Swift, which is Apple's new language, is modeled not after Java, but the ideas that were first popularized in Java became popular in a bunch of other languages. So Swift looks a lot like Java. It's 15 years later, it can be a lot cooler because it doesn't have to keep backwards compatibility with code that was cool in 95. But so we can do this, and we can do system. Yeah. Oh, I know what's going on. I need to do this, right? I'm defining a main class inside the package, right? So it's inside this package. So the rectangle class that I'm going to get is the rectangle class in this package, right? So let me just show the kinds of things that we can do. So I can do, when I print the rectangle R, it's going to call toString to convert it to a string and then print it. So if I execute this guy, I'm going to see this nice stuff. Right? Rectangle width equals width colon 1.0, height colon 2.0, right? That's nice. If I don't have this thing, right? If I were to just rename this guy, right? So now I don't have a toString method, right? And I was to execute that same main, hopefully. I see that. That's the default two-string implementation. It's the name of the class, an at, and then a horrible number. So when you define your classes, you probably want a two-string, right? And we are going to talk more about it now, but does this make sense? Does this class make sense? Simple? No biggie? Now, let's do circle. For my circle class, I have radius, I have a constructor, I have get area, get perimeter. And you also have a two-string. Do you notice what methods did rectangle class have? Get area, get perimeter, right? What does circle have? Get area, get perimeter. Can I do here code that deals with rectangles and circles? Could I have a collection of shapes and then do things with them, right? Not directly, right? Java would say, wait, this is a rectangle, this is a circle, you can't mix and match them. You can't put them into an array, right? However, I can define an interface with the keyword interface. I tend to, this is actually not standard practice in Java, but I borrowed it from C#, what is standard practice. Add an I to the name for interfaces. So if I define an interface, and in your IDE, you say new Java class and then tell it that it's an interface. Horrible, horrible people. Change the thing so it stops adding manure. But I can define this interface iShape has two methods. By default, they are public, right? Because interface usually does only public methods. I think with Java 8 now you can do other stuff. But the methods are get area and get perimeter. Now, in my rectangle class, I can say this rectangle implements iShape. In my circle class, I can say implements iShape. So now both of them implement the iShape interface, and Java will verify that they actually implement the iShape interface, right? That they have the same methods. So
this means that it can do implement methods, or does that make it a subclass?
It's not a subclass. It's similar, but it's not a subclass because the other guy is not a class. It's an interface.
Oh, the shape is an interface.
Shape is an interface. iShape is an interface, not a class. So it is similar to subclass, but not the same.
We are using interface. Okay, so method should be similar.
In fact, if your class implements the interface, it has to define those methods with those parameters. It may define other stuff, but it has to define those.
And what about variables?
There are no variables in interfaces.
Like rectangle class and circle class, variables and methods should be similar.
What do you mean variables? If I define a variable of class rectangle, or do you mean the instant variables like radius and
Yeah.
they don't have to be similar because the interface cannot define them.
Okay.
The interface will not define them, right?
Where do we put the interface? that in the main?
No, just a separate file.
Oh, separate.
You could define everything as static things inside one big class. Or you could have separate files. They have to be in the same package, so they have to be in the same folder. But, or they go in a package.
So what is the advantage of the interface?
Here is the magic stuff. I can do this, right? And let's say that I can do r.getArea. I can do circle C equals new circle of radio 2. And I can do this and this, right? And I was able to do this before, so I didn't gain anything yet. Now, I can use the interface as my type.
Okay.
And I can do this equals to R, and then I can print shape.getArea. It doesn't know whether it's a circle or a rectangle, but it will call, right? It knows that it's an I shape, so it has to have a getArea method. So the compiler will verify that you have a getArea method, which you do because you're an I shape. And then it will call the right method depending on the runtime class. Does this make sense?
So it'll check to see if it like has the two values or the one.
What two values?
Because rectangle has 1 and 2.
Oh,
Circle
it will call the method of the rectangle class. It will call getArea of rectangle. It doesn't, right? It knows that on line 14, when you are running it, right, not when you're defining it, shape is a rectangle. And so at runtime, it will go say, oh, you are referring to this object. What kind of object is this? Oh, it's a rectangle. So I'll call rectangles getArea on this guy. And if I do this, right, on line 17, it will happen to be a circle, and so it will actually call the circles getArea method. Magic.
On line 10 and 11 and 14 and 17 means we have to do only one type of that.
These are examples, right? That depends on what you're trying to do. What do you mean?
Means like system.out.println r.getArea, okay, and on 14 system.out.println shape.getArea.
They're going to print the same value.
Those are the same statements, but in different types.
They are going to have the same result. They are not the same statement, right? They look very different. One has R, the other one has shape. They're not the same statement.
But both are giving for rectangle area, getArea.
Both are printing the same value, yes. I just wanted to print it twice. It's my main. It's my program.
Okay.
That depends, right? Is it a good idea to print it twice? I don't know. That depends on what you're doing. Maybe you should print it twice in two different ways. The point of this main is just to show you that you can, right? So in real life, do you ever do that? Yes, of course. Many times I print stuff twice, right? One of the things that we do at my work is warehouse processing, and so we print labels that we stick to things for the next stuff, and many times you print the same label twice, and you stick it in two different places for whatever reason. So yeah, sure, we printed the same thing twice. Why not? You can. Doesn't mean that you should, right? The should you, it depends on what you're trying to do. And in main, we are just trying to show you what you can do.
This is useful for when you want to create an object that might change form at some point, or you don't know what it is.
Well, the
yet.
object never changes form. The variable does. Right? You
well,
can.
Okay. Shape represents an object, a rectangle object, and now
Shape represents a shape object. And maybe a rectangle or a circle.
okay. So shape is a shape object that has the values of R, and Java knows to treat it like a rectangle for methods.
It doesn't treat it as a rectangle. If rectangle had other methods, right? You can't call them. Like, if in rectangle,
Okay, only for the shape.
only
for
shape,
the
yes.
shape.
It knows how to treat it as a shape. It knows how to treat it as a shape. Right? You cannot treat it as a rectangle when you're referring to it as a shape, because only thing you know is that it's a shape.
Okay, but it's not a shape class. It's a shape
Interface.
interface, which in a way means it's kind of like a rectangle.
If you're thinking about C++, in C++ this would be an abstract class.
Okay.
So if that's what you're trying to map it to, then it's an abstract class.
I like that word better.
Abstract class rather than
Yeah, that makes
interface?
more sense, yeah.
No, interface, right?
Interface does. I don't know what that means off the top of my head.
What do you mean?
Abstract.
User interface, interfaces, right? It's the stuff in between two things. What interface they present to
It
you.
makes sense to your brain, but I like abstract class.
Well, now it's more like the abstract class, but moreover, here's a really cool thing that I can do. I can have a print area and perimeter method that takes a shape, right? And let me be print string. Would be nice, right? This idea makes sense. I can call static. Does this make sense? And when I run it, I get the right stuff. And don't know English. But so I get for rectangle this, its area is 2, and its perimeter is 6. For circle with radius 2, its area is 12.5, and its perimeter is whatever. When I'm writing this function, what can S be? will always be an I shape, right?
Yeah.
Maybe a rectangle, maybe a circle, maybe other stuff, but always an I shape. Does that make sense? Interfaces enable me to write code like this, to write code that's more generic, to write code for I shapes, right? And then make it work for rectangles and circles and squares and triangles and 17 other things.
So S is never, it'll never be a circle or a rectangle. It's always an I shape.
Well,
It's just
at runtime, S may be a circle or a rectangle. It's just that circles are I shapes and rectangles are I shapes.
okay. So they're both.
Yes.
What would happen if you put the circle and just give it 2 values?
Circle
Like
and you give it
circle.
2 values. I cannot give a circle 2 values, right?
Because you already defined.
What would happen if I tried to do a circle
No, like,
C2?
you did 2, 2.
But I need to do it here, right? I need to do it on a. Is there a constructor for a circle class that takes 2 parameters?
No.
Then I get you can't build this thing, right? Because well, there's no constructor for this thing.
So in the shape, you can add a third, let's say, triangle.
Yes.
Okay. And use the same.
Yes. Trying to remember which ones were for the assignment. What are the other simple things? We have circles, rectangles, triangles, regular polygons. Oh, let's do, because I know that I didn't do. Let's implement let's implement trapezoid. What the heck's a trapezoid? Like a triangle but cut off, right? Right? Oh, no, that's not what I want. I don't want a trapezoid. I want a trapezium. I am looking for God. Let's do parallelogram. So let me delete this guy.
Thought about these shapes since 9th grade.
Yes! Isn't that cool? I'm making you remember 9th grade.
Did we do like some proofs and stuff? I don't know. I was 14. This is like 1998 or something.
What's the name of your crush now? Parallelogram. Oh yeah, it's 9th grade, right? So it changed every week. God, no, my son is in 10th grade. My son's in 9th grade and my daughter is in 7th. So no, I don't want to think about that stuff. So if you are a parallelogram, we are going to cheat and give you the 3 pieces, right? Base, height, and base, height, and the other side, right?
You gotta measure.
Sorry?
We only
Is
need
it b squared plus c squared equals a squared? Measure it like a triangle.
But it's not.
You only need base and height, right?
No, you don't. You need base and height and angle,
You need the
right? Because there's basically for areas you only need base and height. For perimeter, what you need is area,
Okay.
not height, right? Does that make sense? So the point is not to learn math, but to learn programming. So we are going to have B, or let's do base, height, and A, right? I'll define, oh, not void, right? What's the other one that we need?
perimeter.
Base of,
Two
Base
turn
times
2 times base plus A, right?
Is the area still based on height?
Yes, but because it's a different, height and A are different. Height is the perpendicular height, and A is the side diagonally.
Basically, if you cut it right there, bring it the other side, it's going to be a rectangle.
Yes, but perimeter-wise, no. Right? The perimeter is bigger.
Yeah.
Because you have diagonal sides. Make sense? So, can I now go to main and do parallelogram P equals new parallelogram. Say my base is 2, my height is 3, and my A has to be bigger than the height, so let's say it's 4, right? And then can I do this?
We gotta go to shape
Why?
because we didn't add it to the shape.
We didn't declare that it was a kind of shape, right?
Yeah.
Even though it has the same methods, it walks like a duck, quacks like a duck, but it's a mallard until you say that it is a duck. In Java, we have strong typing, right? And so you have to declare it. Where do I put that?
Shape.
Not in shape. iShape doesn't say anything.
In the class.
The parallelogram class I have to say implement iShape. I am a shape.
And can you have it implement multiple things?
Yes. Yes, you can with comma. You do implement this, comma, that, comma, that.
So you don't add it to interface.
No, because the interface is open. The interface just says these things, right? And then everybody can implement that interface.
Is there a need to
Is there a need to
do that shape is equal to
do this, implement shape? Is that what you mean?
shape equal to P?
No, now we don't have a variable shape, right? So
Because we have written after the class.
in a previous example, we were using a variable called shape. Now we don't have that variable anymore. And we are passing it as a parameter to my function.
If you have like a supertype and subtype or parent and child, is there any need to make an interface for the child?
No, we are going to talk about class inheritance in a second.
So you're going to usually do one or the other, but you wouldn't do both because it's like redundant.
Sometimes you do both,
Okay.
but if you are doing 7, you are doing it wrong, right? It's more, if you have to implement 3 interfaces and you extend the class, chances are that either your domain is really, really complicated, or more probably you're doing it wrong. You're modeling the thing wrong.
If you have to like make
If
tons
you-
of different interfaces.
Not, it's more if one class needs to explicitly implement 7 interfaces, you are doing it wrong, right? Your concepts are wrong, right? You're doing it too complicated. You can abstract more common stuff. You can, right? You are doing it wrong. Chances are. I mean, there
Okay.
is
But
essential complexity.
Sometimes you might even have a parent and an interface.
Yes, yes. Many times the parent will implement the interface, and so you are not doing that.
Yeah, that's what I was thinking. I thought wouldn't the parent in some cases like do everything that the interface would do? So why would you need? But we can talk about that.
The main reason, yeah, we'll talk about class inheritance, but you can extend more than one interface. You cannot. You can implement more than one interface. You cannot extend more than one class. Java does not support multiple inheritance because multiple inheritance is confusing as hell.
Who support from the programming language?
C++ supports multiple inheritance. So if you want to shoot yourself in the foot, C++ is more than happy to provide you with guns and beef and everything else. So you can shoot yourself in as many different possible ways as you can. But Java tends to be a lot. The idea is to not let yourself mess yourself up. I mean, you can still do horrible things in Java. It's just fewer horrible things, I guess. Multiple inheritance. Sometimes you need it and it's beautiful, but chances are you are doing it wrong. That's the thing, and so they just outlawed it in Java. Even cooler than this, right? I mean, we have seen, right, how you declare that you extend interfaces, right? That you implement interfaces. Classes implement interfaces, right? And we have seen that having an interface allows me to have more generic functions, have polymorphic functions that take the interface and can have polymorphic variables that are the interface type rather than the class type. I can also do cool stuff like this. What did I just declare? An array of I shapes. Right? And I could have functions that take, right? And then rather than doing this, I just do Isn't this cool? Isn't this amazingly cool?
You missed an S and shape right there.
Ah.
Shapes. The one that says print. So
Oh no! What I'm missing here? No, it's shape because it's one. The element is shape. What I'm missing here is passing the out.
oh,
Maybe. Thinking about maybe eventually going. You have two beautiful things and a horrible third line. Why?
you didn't change it to two string.
I didn't define a two string, right? Does this make sense? One. Do this. Ah. I can come define toString, but let me also mention one thing. There is an annotation. Java, since like 5, started defining annotations that can help you do weird stuff. They mark certain things. This is an annotation for the compiler, and it tells it, I am overriding a method that I got from somewhere else. In this case, I can only get it from my shape. So if I'm not doing that, complain. So it is a good idea to mark your things at override.
Wait, what does it do?
It just says, I'm getting this from somewhere else. I'm not, right? I'm overriding it from an interface or class. So if I'm not, it will complain. So let's see. I'm getting this method from an interface, so it's good, right? But if I do at override, this, right? Java is not going to let me compile because it's like, well, no, you're saying that you override it, but you don't.
Okay, because it's not in the interface.
Because it's not in the interface or in a superclass.
But will the interface complain if there is something in the interface that is not in any of the classes?
Java will complain, not the interface, because if I say, if I do stuff like this, Java would complain because I'm not implementing iShape. Implementing iShape defines a contract, right? Defines a promise. I have this area and I
Oh,
have
so
get
you
perimeter.
can't include other methods that aren't part of iShape?
You can, but you have to have the ones in iShape. The problem in here,
Okay, you have to have at least the ones in iShape.
you have to have get area and get perimeter, and in this case, I don't have it, right? Now, if I have them, I can define other stuff. And that's perfectly okay, right? If I mark the methods as at override, then I have to override from somewhere else. And Java will complain if I don't. So it is good documentation practice, right? This one I cannot mark it because I'm not overriding.
It gives you an extra red line just so you can like see it.
Yes, exactly. It is just extra kind of documentation. ToString is actually coming from the object class. I'm lazy. But it would still change it from this horrible thing to just some parallelogram.
So it won't complain about toString because it's already there by it.
Because toString is coming from object, so I'm really overriding it.
Oh, okay.
Does this make sense?
And so the main advantage of the interface is that it allows you to try to explain it. It allows you to just like implement methods, like not knowing in particular whether it's a rectangle or circle. Like
Exactly. It allows me to define polymorphic methods. It allows me to define methods or functions that work on many different classes. It's not so much this method, right? But it is
and does that allow you
this
to actually
method.
do anything different, or is it just more?
Well, what do you mean by do anything different?
Well,
Is it Turing complete either way? It's Turing complete either way. But I cannot write this code if I don't have interfaces, right? I cannot even have an array of, right, things where the things are different. You can't mix apples and oranges.
Okay. That's a good example. Is there any other examples that you can't do with different objects that suddenly you can do now?
Well, I can define methods that take the interface, right? And so I can write polymorphic code, right? I can define variables of the interface type and have them at runtime take any value, right? I can define functions or methods that take a variable of the interface type, and then I can define arrays and collections of that interface type. So it basically enables me to treat all of those things as if they were the same type, because they are, right? The other important thing is that if you do this right, you are creating a new concept, right? To think about how you teach, how you understand things, right? You need concepts, and you can keep 10-ish things in your mind, right? 7 plus or minus 2. But you normally need to start grouping things so you can think about them. So now I can say, oh, I don't really need to know about this guy. I can just think about shapes, right? And shapes are things that have get area and get perimeter. And I don't need the details. In fact, I don't even know the details when I defined this, when we wrote this method, or this method for that matter. Did we know how many iShape, how many classes implemented iShape? No, because we just changed that, right? We just wrote a new class. And that's perfectly okay. Do I know how many classes will eventually implement iShape? No, I don't care. The code will work, right? As long as you respect the contract, as long as get area and get perimeter do the right stuff, then I don't terribly care. So this enables you to have the code written by different people, right? As long as, right, these concepts make sense, right? As long as and this is where computer science becomes philosophy, right? What the heck is a shape? Well, I don't care. But for me, a shape is something that has a get area and a get perimeter.
Right. It seems like we take an object and we ignore like essence, and we just talk about definable, measurable attributes of the object, and that's it. We don't ever really define the object. You know, we kind of delimit it and describe it.
Yeah.
Like we say it has a length and
it enables us to go up one more level of abstraction, right? Classes are very abstract by themselves, right? I define a rectangle class, and that can represent any rectangle, an infinite number of rectangles, right? Because I don't know the width and the height until runtime. Then this is one more level of abstraction. Now I'm going to abstract from a bunch of different classes into this interface concept. Does that make sense? And this is what programming is all about. It's about building the right abstractions. It's about just going up and up into abstraction levels.
And how often would you say that you use interfaces, and how often?
Every freaking day.
And as opposed to just super classes.
Inheritance, class inheritance is a lot less useful in Java because you have interfaces.
So interface is the cool one that you use most of the time.
Interface, you use it all the time. Class inheritance is okay, and we're gonna start talking about it right now, and then talk about it next class. But interfaces are the main thing. In fact, this is one of the things that Java, I think, did right. Before, people didn't really think about it in terms of interfaces, because in C++ they're the same thing. And in Java, by making them different, kind of change how people think about this stuff, which I think is cool. So you understand what an interface is. You understand the syntax of interfaces. Go make sure that we covered everything. But yeah, you can define interfaces. You can change your stuff.
Implements and
Extends will be later.
not extend.
Override. Talked about polymorphism. Actually, yes, sorry.
So overrides basically make sure that you sum that up real quick again. So override.
Override is just an annotation where you say, I'm getting this from some other class. It's
Okay.
for documentation for both for humans, I'm getting this from other class, and from the compiler, so that the compiler will tell you, no, you're lying, you're not getting this from other class, if you're lying.
In case that you forget to put it in whatever that interface is.
Yes.
So if you do have an interface, technically you wouldn't have to put this in your class.
The at override,
No, the whole like get area.
you have to put get area. Because if not, right, because if not, it will tell you you didn't define a get area method.
Okay.
The fact that you have get area just doesn't say what to do. I think now in Java 8 or 9, you can actually have your classes, your interfaces be more like abstract classes, but this is the basic Java stuff. Yes.
So the override, it tell you you're getting from somewhere else, but it don't tell you exactly where you get it
Yeah,
from.
you're not saying where you get it from. Just I'm getting it from somewhere else.
So
It's
interfaces is the
But already-
polymorphism concept. Sorry. That's a simple question. That's like interfaces is the polymorphism concept. There's no polymorphism. Other things too.
polymorphism is other things. Polymorphisms means same name, right? Same name, many shapes. So actually, overriding is polymorphism. It's called ad hoc polymorphism. Inheritance tends to be the most common polymorphism. In object-oriented stuff, when people say polymorphism, they mean inheritance, either of classes or of interfaces. But polymorphism is a more general concept that includes overloading of methods, and it also includes templates. If you think about it, array kind of code, right? An array is a polymorphic concept. It's a thingy that can have, depending on the type, will be different. Array of what? And so that's another kind of polymorphism. But you had a question. You forgot about it. There is one more important concept. We may want to define, keep this generalization concept, right? And so I can have an interface which extends other interfaces. This is very similar to the concept of inheritance that we'll see for classes. And so I can have an interface called iShapeWidthArea that only has getArea, interface called iShape with perimeter, and that only has get perimeter, and then I can have this interface iShape that now extends because it doesn't implement those other two interfaces. And by extending, it inherits the methods from those two guys. Does that make sense? So it kind of cut and pastes the methods from those two guys. It will, what?
Main class or iShape?
This is only in iShape, right? So I would define here
Okay, that means we got 3 interfaces this time.
yes.
Not 1 interface.
As long as we change the class interface, not like we change the type.
Yeah, that's it. It's just the template, so it just changes that to say interface rather than class.
And so the way we're doing it now, there's no way to create an object where you can do get area and get perimeter.
Well, there is, right? iShape. Rather than saying this, now I can just say extend. Sorry.
So when it extends, which one is the one that contains them all? The iShape or the
iShape contains them all.
What's the benefit of doing it this way?
Well, this is horrible overkill, right? But in cases where it makes sense, right, where you have kind of independent concepts, right, or a more complicated modeling situation, then if they are the right concepts, that is, what this allows me to do is have, I could have an iShape, instead of iShape, I could have, say, iShape with area. But that would, right? And that, on that thing, I cannot call get perimeter, I can only call get area, right? And so this would be useful if I had a class, right? Or a bunch of classes for which I can only get their area but not their perimeter. Which in this case, right, it doesn't make any sense. It's just syntactically something that you can do. But in certain conditions, it can be useful. For the most part, you're doing it wrong. We are going towards more and more do simple stuff, do microservices, do small things, self-contained, accessible over the network. So if you're defining a class or an interface hierarchy with several levels and things like that, you may be doing it wrong. It's not guaranteed, but you may be doing it wrong. And so, but it depends on what you are doing, right? You may be doing abstract algebra and then defining this stuff is perfectly okay. But depends on your problem, but chances are that if you're defining big hierarchies with tons of stuff, you are doing it wrong. Make sense? Cool. Then next class, let me just prime your brain. We'll talk about classes that extend other classes. And so when you extend another class as opposed to implement an interface, you get the methods and the fields from the other class. Does that make sense? Extend, it's inheritance, it's class inheritance. You get both the methods and the fields from the class that you extend. We will do examples and stuff.
And if those classes implement interfaces, you get those as well?
Yes.
And then if those interfaces extend to other interfaces,